Oh yeah, let's start 102. Let me to check if it's clear. Shall we? It's clear. Well, it's not bigger. Wow. Can we see? I won't go down. I'm waiting for us. Are we there? Are we there? I think just there are 3 now. Can we hear me? Is it clear now? Is it clear? All right. John Danton, pẹ̀lẹ́ o. Called John Danton, 5 people here. Where is medics? Where is medics now? Yeah, very clear now. Why is it not long like this before? Nonsense. Go and call your friends. You guys are not here yet. We are waiting for you guys. Yeah, all of you that are watching online, we are waiting for you. Go and call them. Go and wake them up. Go and wake them up. Send a message on the group. Disturb everybody. Where are they? They are still stretching. Oh yeah, let's start. Oh yeah, go and call. Now we are starting. What's the first question? Integral of what? 2 raised power log
X log 3 base X
log B 3 abi base X minus 3 raised to the power log what?
Log 2 base x.
2 base x dx. The thing is clear now. Is this the question? It's clear. This is the question, right? Please wake those who are sleeping if you are doing 102. Note 2 log 3 base x equals to 3. Sorry. 2 raised to the power log 3 base x equals to 3 raised to the power log 2 base x. And we prove it on that Sunday. In logarithm, if the exponential base, if the power base remains the same, while the exponential base is swapped with the logarithm, then the two are equal. Do you get what I'm saying? If this base remains the same, but this one can be swapped, yet they remain the same thing. And we prove it in the last class. Since it's a rule in logarithm, rather, we don't need to show the proof. So, like if you have a log base b log c base b, it's equal to c raised power log a base b. Are we together? So if time permits us, we'll be proving that at the end of the day. Now since they are equal, then okay, let's show the proof. Let's prove. Let y be equals to what? 3 raised power log 2 base x. Are we together? We can write the proof, there's no problem. Might push you or whatever, but if you don't write it, you still get your mark. Now let y equals to what? 3. You can say let y be this or this, either of the two. If you say it's this, you want to prove that it's equal to this. If you say it's this, you want to prove that it's equal to this. So let's say y is equal to this. So now we have to take logarithm of both sides. Take the log of base x, because we have base x here. So take the log of base x of what? Of both sides. Of both sides. So this one will give us what? Log y base x, isn't it? Equals to what? Log equals to what? Log 3 raised to power log 2 base x for this guy, right?
So it's 3 log base x 2 minus 2 log.
Okay, is this one that is here?
Yes.
Since they are equal, there's no problem. Like this, are we?
Yes.
So, are we together? So, since these are equal, so now let's continue. Do we grab to this point? Huh? Do we get to this point? Now,
So also she doesn't understand.
waiting, what have we done that she don't understand? Once this is what you need. We are just playing games here. We are coming back to. So now, we say let y be either of this. So if we say let y be either this or this, we want to show why this must be equal to this. And we say let y be this, we want to show why this must be equal to this. So we take the log of both sides in base x. So if I say let y equals to 3 raised to the power log 2 base x, then take the logarithm of both sides in base x, then we have log y base x equals to log 3 raised to the power log 2 base x. How's it? So here we have what? Log y base x equals to, no, this is power. If you have log 2 base a raised to power n, no, it can give you what? N log 2 base a, right? No, all this log 2 base a is like power on 3. Am I communicating? Which means it can come down. So this guy can give us what? Log 2 base x multiplied by what? Log 3 base x. Isn't it? So, if I say 2 times 3, it's same as 3 times 2. Isn't it?
Yeah.
So here I can say Log y base x is equal to what? Log 3 base x times what? Log 2 base x, isn't it? Right? Now this one can go up to become power 2. Can't it, Bossman? Can't it? So I can write this guy as what? Equals to, I can write this guy as log, that might be, I always kneel down times. Log 2 base x raised to power what? Log 3 base what? No, it can also come down to turn to this. No, since it's like this going up, like to become power of 2. Do we grab?
Yeah.
So now, at the end of the day, we can now say log y base x equals to what? Log 2 base x raised to power what? Log 3 base x. Now, this one have log base x, this one also have log base x, isn't it? That means y equals to this. Do we agree?
Yes.
If I say log a equals to log b, if the base are equal, that means a equals to b. Are we together?
Yeah.
So since they have the same base, log base x, that means y equals to this. So hence, or therefore, y equals to what? 2 raised power what? Initially, what was y? So if y is this and we also prove that y is this, that means these two are what? Do we get? That's the proof. Do you want to write that proof? Yeah. Okay, right. We have not started integrating. Okay, let me quickly do the integration. I will clean the board. Since they are equal, since 2 raised power log 3 base x equals to what? 3 raised to power log 2 base x. Therefore, integral of 3 raised to power log 2 base x minus 2 raised to power log 3 base x dx equals to what? Integral of what? 0 dx. If you integrate 0, what do you get? C. Our answer is constant. So if you differentiate a constant, you get 0. So if you integrate 0, you get a constant. So that's the solution to number 1. Hello, okay. Hello, are we following? Do we grab? Those that are watching online, do we understand? All right. Others in call, abi they have slept while they are online. All right. Okay. Sharp. Yeah, let's try to see that now. Don't sleep, oh. Don't sleep, oh. Can I claim it? Is it part of? Yeah, this is the integration. We are only showing that these two are equal. All this one is to show that these two are equal. Because they are equal, if you subtract them, we'll get 0. Now, this question is just like you are integrating 0. That's all. So you want to integrate 0, that's all. For equator 0 for you. This is your 0 now. Can I clean the board? Yeah, let's put it down. Let's not sleep. I'm actually anticipating the exam TV stuff. Yeah. I'm going to be mad. And I'm going to use laptop to stream them rather than phone. So if anyone cannot come, fine. You enjoy it online because it's going to be a laptop and a webcam. Can I clean the board? You are not. OE people of UI, the first and the best, University of Ibadan. The only thing that gave me a disappointment in this quiz, the skill is no fine. The skill no fine. I say it fine. Fine small. Where you fine? No, you are no fine. You are so beautiful. The environment is good. Like the buildings, they were what? When I first came here, I was disappointed like mad. But I thought I was coming to one kind of small London before. When I reached, I just see all those war buildings. Fuck up. Can I give anybody? The only thing they know is book. Other things they don't know anything. Even football they cannot play. They won't let you beat them then. Sports they don't get, high jump they don't get, long jump they don't get, track events they know they do. Feed just dey there for fun. Now book now you go see that. Now what's question 2? Question 2 is also simple. Integral of 5 raised to power 5 raised to power 5 raised to power x dot 5 raised to power 5 raised to power x dot what? 5 raised to power x dx. Now, let u be equal to what? 5 raised to power 5 raised to power 5 raised to power x. Why? Because if you differentiate it, it's going to give birth to everything here again, such that if you make the end descent of the formula, it will cancel. Just like at the end of the day, you are integrating u du. Are we together? Now, if you want to differentiate something like this, probably maybe I have if y equals to 2 raised to power 2 raised to power x. If I want to find my dy over dx, it's going to give me 2 raised to power 2 raised to power x ln 2 multiplied by derivative of the power d2 raised to power x over dx. Are we together? That's the rule. That's the rule. Like this is it. If you have note, let me write the formula for you. Note the derivative of, let me say, a raised to power f of x, that is a function of a of x which have another power. Am I communicating? We assume that all this is the power now over dx is equals to the derivative of something like this, regardless of the power, whether it's just 1 or it's more, equals to what? It's going to give us what? A raised to power f of x ln a, then f prime of what? F prime of x. Are we together?
Okay.
Yeah. That is, you are going to differentiate that power. So this is the rule. Note, you can write this guy here. Note, if you have a derivative, the derivative of this equals to, then the function itself, ln a, then the derivative of the power. Are we together? So now, therefore, dot. If you, okay, we already write that. That means du over dx is going to give us what? 5 raised to power 5 raised to power 5 raised to power x ln 5 dot the derivative of the power. What's the power? 5 raised to power 5 raised to power x, right? Yes. Dot the 5 raised to power 5 raised to power x over what? No, we have to differentiate that one again. We are still going to apply this formula too. So I don't want to write it at once. Now let's bring this guy out. Now I want to differentiate the 5 raised to power 5 raised to power x over dx. It's same thing as what? 5 raised to power 5 raised to power x ln 5 d 5 raised to power x over what? dx. Bring this one outside. The 5 raised power x over dx equals to what? 5 raised power x ln 5 dx. The power now is x, right? If you divide x, you get 1. So we stop here. Do we get that?
Sure.
So that's that for that. That means hence, now let's write our du in full now. Hence, sorry now. So hence, I hope nobody is complaining yet.
No.
Hence, du over dx equals to what? 5 raised to the power 5 raised to the power 5 raised to the power x ln 5. Now what is this guy? The derivative of this guy is what? 5 raised to the power 5 raised to the power x ln 5. And this, the derivative of this is what? 5 raised to the power x ln 5. All this one is the derivative of this. This is the derivative. Do we get that? Do we get that? Do we get it to this point? So now if you want to write now, I want to write this guy. 5 raised to the power 5 raised to the power 5 raised to the power x, which is this. This is the ln 5. Now I want to write the derivative of this. I know that the derivative of this is this. So I'm writing this instead of this. I'm writing this here, which is 5 raised to the power 5 raised to the power x ln 5. Now I want to, instead of me to write the derivative of this here in form of this now, since I already differentiate this to be this, then this now be 5 raised, instead of the 5 raised to the power x over ds, no, the same thing as this. It now be 5 raised to the power x ln 5. Do you get it? So here now our what? Du over dx equals to what? 5 raised to the power 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 x dot 5 raised to the power 5 raised to the power x dot 5 raised to the power x dot what? Ln 5 all what? Cube. Now what will be dx? No, if you make dx the result of the formula, therefore our dx equals to what? Du over what? Yeah, du. No, first, you can first make du the result of the formula. You know, if you cross multiply, dx will come here. So we make dx the result of the formula. That means divide both sides by this guy. So dx will give you du over 5 raised to the power 5 raised to 5 raised to the power 5 raised to the power 5 raised to the power x dot 5 raised to the power 5 raised to the power x dot 5 raised to the power x dot ln 5 what? All cube. Now let's finish the whole thing here. This is the last page now. So let's write this integral. This now gives us what? Integral of what? 5 raised to the power 5 raised to the power 5 raised to the power x dot 5 raised to the power 5 raised to the power x dot 5 raised to the power x. What's our dx? Instead of dx now we write what? Du over what? 5 raised to 5 raised to the power 5 raised to the power 5 raised to the power x dot 5 raised to the power 5 raised to the power x dot 5 raised to the power x dot what? If I all what? Shara. Are we together? What's ln 5 all cube is a constant. It can come out. No, it's 1 over there. So here we are 1 over what? Ln 5 all cube. Integral of what? Du or 1 du. Now if you integrate from what do you get? With respect to du, you get u. If it is dx, you get x. So here we have 1 over ln 5 all cube multiplied by what? U plus c. Are we together? So now what's our u? So at the end of that, our answer equals to what? So our final answer now will give us 5 raised to the power 5 raised to the power 5 raised to the power x plus c over what? Ln 5 all what? All cube. Plus c. This is the answer. Clear? Is it hard? Very simple. Yeah, let's write it before I clean the board. You are not on the first test mode. You don't need to be there now. Should be on the second one. Do we understand what I just did? You know, go far now. Hello, do we grab? Hello, boys. Hello, guests. Okay, somebody said no. Somebody said yes. That person that said no, screenshot. Screenshot it now before I clean it. Tommy, mama, Tommy, you come online, sha. Praise God, though. Some people say I can see some yeses, I can see some no's. Those people that are saying no, just screenshots. Okay, thank you. From no to yes. All right, no problem. Who else do not understand? Just take a look at what I did step by step. Take a look at what I did step by step. And you are submitting tomorrow, no problem. I screenshot it, write it when we are done. Just screenshot it, write it. Screenshot it like that and write. Let me see how it looks like. It's even very clear. Very clear. Okay, maybe. Let me check my percentage. 8%. Chai. Thank God, though. The phone just die for just. But if I dey charge this thing, go dey hot like. Ṣé ṣé pé power bank ti kú à? Wọ́n máa kú o. Charge. Who has power bank? Who has power bank? Please lend me. Kí fóònù má lọ kú. Yeah, I'll be starting number 3 soon. This girl is not. I said, "Who has power bank?" He said, "Yes, I do." Show the YouTube load from power bank. Thank you. You can remove it. Want to give power bank on YouTube, ni? Should we do number 3? Are we ready? If I was in there and you have not subscribed to my channel, before I beat you now, better go and subscribe. I hope everything is clear now. Can we see the board clearly, everybody? All right, let me feel the. Pay attention to that number 3. Oh. It's kind of crazy. I'm even afraid of that number 4 now. Shall we? Shall we? Mass is sweet, though. I have a question. Share this one. Yeah, exactly. This is the rule. If we have a function with a power, the derivative will first be the whole function, lane of the exponential base multiply by the derivative of the power. So that's why when we are differentiating this, we first have this ln of the base, derivative of the whole power. I know the whole power now, you still have another power. So I have to bring this out and differentiate it separately to give me this ln 5 derivative of this power. So I brought this one out to differentiate it separately. This ln 5, the derivative of the power x, differentiate x to get 1 here. So I now take this to this, this one and this represent this. So I take this instead of this now enter. So instead of this, the whole of this now enter. And I have everything here. This is just like application of the formula directly. If you want to solve it one by one, like we'll be using like multiples of chain rule. Right, and say let this power be equals to u, then we start. So if you say let the power be equals to u, let u equals to 5 raised power x. If you don't want to apply this formula direct, we still say let this be equals to something. Let it be equal to 5 raised power x. So we now start from this place. Then now substitute the v back, substitute u back, then come back. But it's going to be kind of long. And just apply this. So now, what's that number 3? Number 3 says what? Integral of what? Dx over 2 sine x over 2 and cos x over 2 plus 2 into 1 plus cos x. Wow. Let's solve this now. I should be able to solve it. Yeah. Now there's an identity for this guy. Note 1 plus cos x equals to what? 2 cos square x over 2. Am I right? If it is minus, it will be sine. Let's confirm. 1 minus cos x is 2 sine square x over 2. 1 plus cos x is 2 cos square x over 2. Let's confirm that. I think that's right, isn't it? Yeah, that's right. So this guy gave us, please let's keep confirm. Dx over what? 2 sine x over 2 cos x over 2 plus what? 2 times 2. 4 cos square what? X over 2. Is that clear? So that part, which one is not clear? Note 1 plus cos x is the same as 2 cos square x over 2, trigonometric identity. Then if you multiply it by 2 times this, you get 4 cos square x over 2. This is the only thing we have touched. So here now we have equals to integral of dx over, what is common to both? Cos x over 2, right? Bring it out. Cos x over 2, open bracket, what do you have left here? 2 sine x over 2 plus what? Which one? Yeah. Okay, I get, but I don't want to use that one. Like we should change this to sine x, are you? That's what you are saying. Now, if it becomes sine x into 2 into 1 plus cos x, this guy is kind of, we are still going to manipulate. Like I've done something like this, but I think it's complex. It's like small body, big engine, the way you are looking at it. So to be clear, so I think it's better to change it to half angle everything. But maybe when we are done with this, we try the other one so that I can show you what is also here. So here, I would prefer to bring out 2 instead. I would prefer to bring out 2 instead. It's actually because of this plus that is here. That plus is the big problem there. Do we get? That's why we cannot afford to change this to sin x. This plus, as it is very small, very easy, this place is mad. So we have to bring in identity for it to eradicate it. And the only identity that can fit is x over 2. So if you're having angle of x over 2, so it's better to leave all this one as x over 2. Are we together? So yeah, let's bring out 2 cos x over 2. What do we have left here? Sin what? X over 2 plus what?
Plus
2 cos what?
m cos x.
Cos x over 2. What is next? Bye.
If we make t equal to tan x over 2 and find our sin and cos.
Yeah, I want to bring in tan on. That's what I'm thinking about.
So I'm using
What guys we do that day? We have this thing should come. Okay, yeah. I think. Well, let me think. I'm coming cos x over 2 divided by cos x over 2. This one coming. Yeah. Multiply the denominator by 1. So if you multiply by 1, we have not changed anything. Right? If you multiply by 1, have we changed anything? No. Only the denominator new, but I want to write my 1 as what? Cos x over 2 divided by what? Cos x over 2. Are we together? We are bringing in tan now. So this guy gives me integral of what? Dx over what? You can ask how do we know this is what we have to do? Well, number one, if you have not seen it before, you may not know what to do. And number two, I want a tan identity because I know that, listen, I know that if I divide this guy by cosine, it will be tan, right? And if I divide this by cosine, so I will have tan here. And yeah, if I divide this by cosine, we have tan. If I divide it by cosine, we have a constant 2, right? And if I multiply this, if I multiply this by cos, I will have cos square something, which I can change to 1 over sec square something. And if that sec should go up, it will become sec, of which if I differentiate the tan at the bottom, I will have the sec at the top. Okay, let's do it. Don't worry. So let me write. I should have done what I want to do now, but let me just split it. Now I want to bring this up. This is just 1. It has not changed anything. I want to bring this upper one together with this. So this guy give me 2 cos x over 2 multiplied by what? Cos x over 2. Now the up here now, I brought it here. Open bracket. This guy I want to bring it to this denominator. Sin x over 2 divided by cos x over 2 plus 2 cos x over 2 divided by what? Cos x over 2. Do we get it? No. If either I say over just 1, I can still split it. This is what I did here. Everything over cos x over 2. If I want to remove these 2 back again, they can come here and become cos x over 2 divided by cos x over 2. Are we together? So here now we have what? Integral of what? The x divided by what? This guy times this guy. What do we have? 2 cos square what? X over 2. Sin x over 2 divided by cos x over 2. We have what? Tan x over 2 plus 2 cos square x over 2 divided by cos x over 2. 2 cos x over 2 over cos x over 2. That's 2, are we? Clear to that part? So here now we can have integral of dx divided by 2 over sec square x over 2. Agree? Cos theta is 1 over sec theta. Cos square theta will give us 1 over sec square theta. So 2 multiplied by cos square theta will give us 2 times 1 over sec square theta. So 2 multiplied by cos square x over 2 give us 2 times 1 over sec square x over 2. Don't make mistake, these 2 must be at the, don't say the 2 is at the denominator, because here you're having 2 times cos square x over 2. And cos square x over 2 itself is 1 over sec square x over 2 times 2. You know that is at the numerator. Are we together? So we have this guy. Now, so here we have now tan x over 2 plus what? Plus 2. So this guy gives us integral of, you know, this guy can go up. This sec can go up. Now this 1 over 2 can come out. So here we have 1 over 2 integral of what? Sec square x over 2 divided by tan x over 2 plus what? Plus 2. See, if you have some people are confused, why is this one? Why it can go up, but they are confused. Why is it not 1 over here? It can't be 1 over, because if you have a over b over c, if this is coming up, it will not be under again. Like here now, we can have a divided by let me say a divided by b over c, which is same as what? A multiplied by c over b. So this will just be, we have ac over b, and this b there is like our 2, isn't it? So a over b over c, dx over 2 over this. So this b is like our 2 before. So here you can have what? 1 over b times what? C. Just like we have 1 over 2 times what? Sec square x over 2. Are we together? So 1 over 2 times sec square x over 2. So we have this guy here. So here now we can now start to use substitution. Like we're almost done. There is nothing there again. So let u be what? U be what? Tan. But there's nothing to do with it. We don't even need to be doing that. We can just apply that formula. You know that formula that says what? If when you have integral of f prime of x over f of x, you don't need to be saying this solution and start integration. You can just apply this formula directly. It's allowed. But you have to write it, you have to state it before you use it. If you don't know how to state it, it's better you solve it. Because if you use it without stating it, you are wrong. So integral of f prime of x over f of x equals to ln f of x if wait, I'm right. Okay, sorry. Integral of this is not integral of f of x over g of x equals to ln g of x if I learn the right hand then, God. If g prime of x here equals to f of x, do we get integral of f of x over g of x dx, add your dx to equals to ln g of x plus c if g prime of x equals to f of x. That is integral of a rational function. Rational function is when you have a division, numerator over denominator. Integral of a rational function equals to ln of the denominator if the differentiation or if the derivative of the denominator is equal to the numerator. So integral of this equals to ln of the denominator if g prime, that is, if you differentiate the denominator, is equals to the numerator. Are we together? So this is how to state it. Once you are done stating, you can just apply. Now, if you integrate tan x over 2, what do you get? It will be 1 over 2 sec square x over 2. No, this is if you integrate tan x, actually it's sent as 1 sec square x. Because you have to integrate the inside too. To differentiate the inside. Like if you integrate, you have to multiply by the differentiation of the inside. Are we together? So now what's differentiation of x over 2? 1 over 2, right? So now if we integrate down, this 1 over 2 is even useful. Maybe we should just, let's return it inside. Do we get? Are we together? Can leave it outside, there's no problem. But return it inside so that the derivative of this can give the whole of the numerator. Am I communicating? So if we differentiate tan x over 2, we get 1 over 2 square x over 2. The derivative is 0, so it doesn't have any effect. So since the derivative of the bottom can be found at the what? The numerator, then the final answer, this is dx, right? So our final answer now is what? Lane what? Tan x over 2 plus 2 plus what? Plus c. That's the answer. Is it clear? No go far.
Sorry. How is that called x over 2 because I'm x
Which one?
that took us square x over 2. How does it give us x over 2?
Shade 2 cos.
This took us x over 2.
Shade this one.
No.
This one. Intrigue. Cos equals to 1 over sec. No, sine is 1 over cosecant. So if this is square, you have square here. If this is theta, you have theta here. If this is theta over 2, you have theta over 2 here. So cos square x over 3 gives us 1 over sec square x over 2. But because you're having 2 times, this one will be 2 times. It's like 2. Now 2 cos square theta over 2 will now give us 2 times 1 over what? Sec square theta over 2. If 2 is multiplying 2, we also multiply the. So this will now be 2 over. That's how we have it. Wake everybody that is sleeping. Wake them, wake them, wake them. Should call number 3. Please let me ask them online. Are they following? Did they understand? Or do they anyone? Wake. Is it like it's sweet now? Now we are moving to the greatest number 4. Number 4 alone can give birth to the remaining question. Please let's calm down and write this very well because me I want to calm down now. I'm even afraid to start at number 4. Do we understand, guys? Hello, guys. Do we grab? Have we slept? Hello. Yeah, hello. I'm doing with live stream. They are already streaming. You want to get a sticker, don't? That sticker I just sent now. Send it to me on WhatsApp. Let me save it. Can I tune the voice? Number 4, Lord, help me. Okay, all right, thank you. Shall we? No, we still have a long way to go. We are still coming back to do some. When we are done with this, I will now give us break at all. I will give us 15 minutes break. Then we'll now come back for match 101. Right. Once we are done with number 4, the rest will be their babies. That number 6, do I still remember? Can I clean the board? Number 4. Lord. Yeah, I think it's getting clear.
Yeah.
Please, this formula is very, it will save a lot of stress. If you can state it correctly, you can just apply it directly without solving. As soon as I don't remember how to state it now, I will still say let u be tan x over 2 plus 2. The u over the s is this. Make the s the square root of the formula, then bring it back. Then this one will now cancel out. It will now remain 1. I will now be integrating 1. I will now get u plus c. Are we together? It will now remain 1 over u rather. If I integrate, I will now get u plus c. I will now put my u back. Someone said. How I got the final answer? This is the formula. You may decide not to apply the formula. You may say let u be tan x over 2 plus 2. If you differentiate it, it will give you this. You now make the u the subject of the formula. If you make the u the x rather the subject of the formula, if you say let u equals to tan x over 2 plus 2, now du over dx equals to 1 over 2 sec square x over 2. Now if you make the x the subject of the formula, dx equals to what? Du over what? 1 over 2 sec square x over 2. Now plug in the x here. No, this is already u now. No, we already said let u be this. So let's say this is already u. Now put the x here. Since our dx is this, you have the u over what? 1 over what? 2 sec square x over 2. This will cancel this. You now have 1 over u du. Now be integrating 1 over u du. If you integrate 1 over u, you get ln u. Then what's your u? Bring it back. You get this. So that, but instead of all that stress, we have a formula already in integral. Instead of all that stress, so this one is 1 over 2 sec square x over 2 divided by tan x over 2 plus 2 dx. So the formula says if we have integration of f of x over g of x dx, the answer equals to ln g of x, the ln of the denominator under one condition, and the condition, the integral of f of x over g of x dx equals to ln g of x if and only if g prime of x equals to what? F of x. Then if you can state this, then just put ln g of x there as the answer. What's our g of x times this? Then this is your plus c, sorry. Ln g of x plus c, don't eat the c. Without the c, you get 0. Ln g of x plus c, if g prime of x equals to f of x. Now, can I clean the board? Every doing cow. Ṣé wàá lọ jọ́ọ̀gì díẹ̀? Can I clean the board?
Yeah.
Stretch your body. I'm still looking for one day that I'll be teaching that. I'll be the one that I'll be tired. Why students say, Esther, don't be tired. Let's go. But I've always been student. Why? What's happening? Why is it not me? Why is it not me? Shall we? Let me go call that question first. Hey, should we write it? Fourth root of tan x green. Sharp. Small body, big what? Big engine. Now I will not use partial fraction. If I don't use partial fraction, you might be consuming more than 2 pages of our education. But let's just, find a beautiful way. Now let's follow me, please. Let me divide this body. Please, let's pay very good attention to this one. Let U equals to what? Now, note, if you are integrating, we can integrate a particular question and get different answer, and yet we are correct. But how do we verify if both of us are correct? If we differentiate back, both answers must resolve to the original question. Do we get? So for integration, we can get different answer. Yeah, it's valid. But if we differentiate it back. So this question I want to solve, if somebody use fire fraction, his answer will be, the structure will be different from what you want to get. But once you are done, differentiate whatever you get, put it on ChatGPT to give you 4 root of tan x. Are we together? So here we have let U be what? 4 root of what? Tan x. So that means if you take the 4th power of both sides, what are we going to get? U raised to power 4 equals to what? Tan x. Am I right? Take the 4th power of it, if you cancel the 4th root. You take like this, like raised power 4 raised power 4. So this 4th root we cancel, you have tan x left here. This one will be U raised power 4. Clear to that part? Now, if you differentiate U raised power 4, what do we get? 4u cubed du. I mean, if you differentiate tan x, you get what? Z square x dx. I mean, you may start by saying du over dx equals to, but because this guy has power already, assuming there is no power, you can just start with du over dx equals to whatever. But because of the power, you have to differentiate it separately. So differentiating u raised power 4, that's 4u cubed du. Differentiating this separately, z square x dx. So now, making dx the set of the formula, that means what? Dx equals to what? 4u cubed, abi? Du over what? Z square x. Note z square x equals to what? 1 plus what? Tan square x, right? Then that is, so if u raised to power 4 equals to tan x, therefore tan square x equals to what? U raised to power 8. Am I right? If u raised to power 4 is tan x, if you square tan x, then you have to square this. Is that clear? If u raised to power 4 is tan x from the above, then tan square x will give us u raised to power 4 squared, which is u raised to power 8. Clear to that part? That means our dx equals to what? 4u cubed du over what? 1 plus what? U raised to power 8. You know, z square is 1 plus tan square x. Z square x is 1 plus tan square x, the second or the third trig identity. And since we've shown that our tan square x is 2 u raised to power 8, that means z square x is 1 plus u raised to power 8. So our dx is 4u cubed du over what? U raised to power 8. So therefore now the question becomes integral of what's 4th root of tan x? U, abi? What's our dx? 4u cubed du over what? 1 plus u raised to power what? 8. So the question now becomes integral of what? 4u raised to power 4 du over what? 1 plus u raised to power 8. Clear to that part? I have not started anything now, okay? But if there is something I want to bring in, you'll be like, you know, it's in the power. Do we get into this part? Now make the end side of the formula is clear to this part.
Start from the beginning.
Oh, yeah, okay. Now let me come again. Now the thing is that I don't just want you to just write the assignment. Like, I want to understand even questions like this, that you'll be able to solve it. Like, they will not even beg you to solve it. Just like, let me just enjoy solving this thing. So yeah, we have said let u be what? 4th root of tan x. So u raised to power 4 equals what? Tan x, right? So let's differentiate u raised to power 4. That's 4u cubed du, right? Differentiate tan x. Square square x dx. Make the x the center of the formula. That means dx equals to what? 4u cubed du over what? Square x. Now note 3d now. Square x equals to what? Tan square x. And if from above, what is our tan x? U raised to power 4. If tan x equals u raised to power 4, then tan square x will give us what? Isn't it? Equals to what? U raised to power 8, isn't it? Huh? That means hence square x will be what? 1 plus what? U raised to power 8. Are we together? Yes. So now let's write the question. The question is integral of, this guy is already u. Abi? Yes. So let u be this. What's our dx? Okay, let me write it first. Therefore, dx equals to 4u cubed du over what? 1 plus u8. You know our square is already 1 plus u8. So the question now becomes what? Integral of this now is equal to this next step. That's why I use arrow. Let me even put it down here. So the question now becomes what? Integral of what? U, this guy, dx. What's dx? 4u cubed du over what? U raised to power 8. Which gives us what? Integral of what? U times 4u cubed. 4u raised to power 4 du divided by what? 1 plus what? Clear to that part? Now the next thing to do now, divide everything, divide both the numerator and the denominator by u raised to power 4. Is that so? Wait first. Yeah. So divide all through by what? U raised to power 4. So here now we now have what? Integral of what? 4, right? Over 1 divided by what? U raised to power 4 plus what? U raised to power 4 du. Are we together? Like we are dividing the numerator. No, it's just like you divide. If I say integral of a over b, so I want to divide both the numerator and the denominator by c. I'm going to give integral of a over c divided by what? B over c. The fact that I divide both by the same thing, I've not changed the question. Let me prove it. This gives us integral of what? A over c divided by what? B over c, abi? Then as integral of a over c times what? C over b. This comes with c over a over b back. What I'm doing here, I'm dividing both the numerator and denominator by u raised to power 4. So now if I divide this one by u raised to power 4, it's just like this one now becomes integral of 4u raised to power 4 over u raised to power 4 divided by 1 plus u8 over what? U raised to power 4. And now I can split this guy to 1 over u raised to power 4 plus u8 over what? U raised to power 4. So 1 over u raised to power 4 is this. U8 over u raised to power 4 is this. 4u4 over u4 is 4. Is it clear? So we got to this part now. What's next? What's next? What's next? How come? Let me remember. I pray I will remember. Be writing it, let me be remembering. So I have M to tap. What's next? So I have with the law farm of kilo. square. 1 over u square. 1 over u square plus u square all square. Okay, this one will be 1 over u square plus u square. 1 over u square plus u square. So this guy is 1 over u square times 1 over u square. 1 over u square. 1 over u square times u square. 1. 2. That's already 2. Okay, minus 2. Minus 2 sharp. So this one is balanced like this. You want to write 4. This one is balanced. So here we have minus 2. So 4. The answer is so you cannot write that root 2. This is not like difference of 2 square, which can be written as wait, calm down. I'm coming, oh guys, I'm coming. Let's just remember this part, guys. I'm moving my with 2. So let's say this guy is 1 over u square plus u square. Minus 2. 1 over u square plus u square plus 2. Let me check. I hope we are getting it. Just stay, oh, don't leave. Oh. Just stay. Give me. I don't want to cut this thing. Oh. Shit. Let me just wrap my brain. I will get my way around. Where's the duster? Mm-hmm. 1 over u square plus 1 over u square plus u square plus root 2. I can see right now 1 over u square plus u square minus u square is minus root 2 plus root 2. Right, so what of the denominator? The denominator and the denominator is okay. You get away right. 4 equals to 2u square. You get 2 square. 2u square into alright, 4 equals to 2 plus 2 equals to 2 equals to what? 2u or 2 root 2u square into u square minus root 2u square plus 1 plus plus u square plus root 2u square plus 1. Let me check. This goes yes 2u square. Okay, let's say this is 2u square. 4u square. Yeah, 4u square. It's minus, yeah. Don't worry, I'm getting there. 2u square, u square. This one is plus. Okay, this is plus. Then this is minus 1. Yeah. So, this is plus. Okay, this is so 2 root 2 u square. So 2u square. 2 root 2u square. So then now we have. So this will be minus. This will be minus. Yeah, sharp. Can we proceed?
Before we proceed, so you ask me that.
Yeah.
Which
Which one? Which denominator? Say this one. U raised power 8 over u raised power 4. That should be u raised power 2. I hope you are watching. U raised power 8 divided by u raised power 4 equals to u raised power 8 minus what? So it's 4, it's not 2. Indices now, assuming it's multiplication, it will be what? U raised power 8 plus 4. If it's division, it will be minus. I hope that's clear. Now, I want to do a beautiful manipulation here. Please, babe, are we done? Are we done with this part? Please help me to wake up. Please help me to wake up. Wake everybody, please. Okay, let me manage this part first. Now, this integral gives me. Please, let's look here. Here I have integration of 2 plus 2. I'm changing 4 to 2 plus 2 divided by 1 over u raised power 4 plus u raised power 4 du. Then even me, I forgot when I saw it, but I was able to. So there are times that you may not even remember, but you just call back your brain. Like you invoke it out. U raised power 4. So which can be written as integral of what? 2 over 1 over u4. Do we agree? Plus u4 du plus what? Integral of 2 over 1 over u4 plus u4 what? Du. Are we good? Are we good? Now I want to write 2. Yeah, to 2 plus 2. So I now split it. No sense. If you have a plus b over whatever, it can be a over whatever plus b over whatever. You get it? So like this, like our whatever now. Can we proceed? Yeah. So now, okay, God now. Now you see this denominator, 1 over u raised power 4 plus u raised power 4. 1 over u raised power 4. 1 over u raised power 4 plus u raised power 4 can be written as 1 over u square plus u square all square minus 2. Expand this guy, subtract it from it, we get this. Yeah. 1 over u square, that's 1 over u4, abi? 1 over u square times u square, that's 1. U square times 1 over u square, that's 1. 1 plus 1, 2. 2 minus 2, 0. U square times u square, u4. Write this in your note, expand, you will get this. Are we together? It can also be equals to 1 over u square minus u square all into square plus 2. Let me write it so that there will be enough space. Show this one. Shit. This is du. Please, let's pay attention. Equals to integral of 2 over 1 over u4 plus u4 du plus integral of 2 divided by 1 over u4 plus u4 du. Are we together? So I'm just splitting these two on both denominator. So note 1 over u4 plus u4 is equal to m to make this get. Equals to 1 over u square. Why are you sleeping? U square all into square minus 2, which is also same thing as 1 over u square minus u square all into square plus 2. It can either be the 2. It can either be the 2. If you expand this minus 2, you get this. If you expand this plus 2, you get this. You can try it in your notes. So this denominator can be represented in this pattern. Also, 2. Now we're about to do something. 2 is equal to 2 root 2 u square you will see whether it's equal or not. It's because of this denominator. So we need something at the numerator that can come. I'm still going to change this guy. Just understand what I'm doing and be writing. It will be long. Yeah, that's why I don't use fire fraction. This one, once I'm done with this part, I will not use more than this part again. We will arrive at the final answer. So here we have 2 equals to 2 root 2 u square all into bracket u square minus root 2 u square plus 1 minus minus u square minus root 2 u square minus 1. Let's confirm if they are truly equal. If this is truly equal to 2, this plus. Let me check very well. Okay, this minus 1, this plus 1. U square minus u square cancelled, Abi? Okay, sorry, this is plus. Let's still check. U square minus u square cancel, Abi? Minus root 2 u square. You know this will not be minus. Minus root 2 square. That's minus what? I don't like what I'm seeing. Wait. There's a way I write it. I wrote it then. Let's just check. Root 2 follow your go and be out. This square cancel this square. This one already. Okay, this one is not cancelling. This be 1. Square plus this square, we have 2.
Sorry,
He said instead of 4 divided by 1 over 4. I don't make mistake, Abi. There's no mistake here. It's even this one mistake. Let me send this. I divided the numerator and the denominator by u raised to power 4. If you divide 4 u raised to power 4 by u raised to power 4, you get 4. 1 over u raised to power 4, you have 1 over u raised to power 4. U raised to power 8 divided by u raised to power 4, you have u raised to power 4. That's all. Divide everything by u raised to power 4, you get that. It's not a mistake. Let me see what this thing came the other time. Now why don't disappear like this? Minus 1 plus 1 gone. U plus this, minus. Okay, this one give us 2u square No share the right. This already cancel this. You have the minus. Here to cancel the minus root 2u square. Okay, 2 root 2u square. Root 2 square plus root 2u square. 2 root 2u square. If this is plus, then this is minus, then this already cancelled this. This already valid. This is my okay. This okay. It's balanced now. Sharp. Now let's check if it's correct. Are we together? U square minus u square is 0, abi? This is 1 minus 1 is 0, abi? Minus root 2u square minus root 2u square. That's minus what? 2 root 2u square. Wait, there's something, it's not yet done. Okay, this should be minus 1. Yeah. Wait, I'm coming. Wait till they drop like this. Shake it, don't they happen? Wait, I'm coming. I need to check it, and I don't want to check it. Let me check it. Let me check. You guys are sleeping already. I'm coming, guys. Just give me a few minutes. I want to check something. Let's proceed. Not the one the guy is saying is correct, though, but it's another thing I want to apply. We are not dividing by u raised power 4 again. This one is long. So we are not dividing by u raised power 4 again. Well, let's listen. 1 plus u raised power 8 equals to u raised power 4 plus 1 all square minus 2u4. Let's check. If we square this, are we going to get this? u4 square, that's u8, have you? No, write it in two places. We have u4 times 1, have you? We also have another u4 times 1, which should be what? Plus 2u4, isn't it? We have 1 square, which is what? 1 minus 2u4. So this will cancel. We have 1 plus u raised power 8. Expand this, we get it. Now we can write 2u4 as what? Root 2u square all square, isn't it? 2u4, root 2 square is 2. U square is u4. Are we together? So which is same thing as what? U raised power 4 plus 1 square minus root 2u square all what? Square. So this guy is like difference of 2 square. Are we? So here we are going to have u4 plus 1 plus u4 plus 1 plus root 2u square, u4 plus 1 plus root 2u square into what? u4 plus 1 minus what? You know, it's difference of 2 square. So u4 plus 1 plus root 2u square into what? u4 plus 1 minus root 2u square. Now let's write it very well now. Let's make it u4 plus root 2u square plus 1 multiplied by what? u4 minus root 2u square plus 1. If you expand, we get 1 power 8. So that's where we are coming from. So now that's the denominator. For the numerator, 4u4 can be written as 2u square into u4 plus root 2u 1 minus minus, I'm coming, u square plus root 2 u square plus 1. Let me check, let me confirm it first before we conclude. This minus this gone. This minus this gone. This minus but it's gone now. Okay, let this be minus. Yeah. So this will be this plus this, we have 2 root 2u squared. So 2u squared times this should be 4. So this should not be. I'm coming to. I think, yeah, this will be u squared. Yeah, this is correct like this. 4u raised power 4 equals to u square into bracket u square plus, now let's prove it. U square minus u square is 0, abi? Root 2u square minus times minus plus. Root 2u square plus root 2u square, that's what? 2 root 2u square, right? That means we still have u square outside. 1, you know, this, we are not multiplying this minus, so we are just subtracting. 1 minus 1. So this is like what we have now. So is this equals to this? Oh, there, I'm coming. This, something has to do. Okay, this is root 2. Yeah, this is root 2. So if this is root 2, I think this will be equal like this. U square times u square, u4. 2 root 2 times root 2. That's 4. Isn't it? So it's equal to this. Yeah, they are equal now. So now, I think now we are getting to our promised land. So the question now becomes integral of, now instead of 4u4, what do we write? Root 2, abi? And since root 2 is a constant, let's bring it out. So you are now have what? U square, abi? U square plus what? Root 2u square plus 1 minus what? Let me put it this way, smaller bracket. Minus what? U square minus what? Root 2u square plus 1 over, what's 1 plus u8? You know the denominator is 1 plus u8. What's 1 plus u8? This. So here we have u4 plus what? Root 2u square plus 1, right? Then we have u4 minus what? Root 2u square plus 1. Are we clear to that part? We are not clear. No, they are clear. Even myself, I'm not clear. But this is correct, Charlie. du. There's something I'm checking there. This like, what we have to do is we open the bracket. Okay. Now they are open. This has to be, how do you get? This guy still remain 4. I need to eradicate this 4. 4 MB. Oh, now. Okay, divide by u square. Divide by u square. This one go. This one go. Oh, now I'm 1 over u square. Oh, something is missing. They are equal like that, but something is missing. Something has to cancel out there. Something has to cancel out. Let me. It's correct in this part. Let me check this identity again. Don't worry, just chill. I'm coming. Let me just find a way to do it so that you guys will write it. We might explain again, but let's write it out first. What's the next thing there? Here we have this guy. Let me quickly check something. I've seen what I need. Can we all see the board? Is it clear? Please let me check there. Is it clear? I've seen that U squared that is there should have been U4 because it will still not affect it. This one should have been U4. No, it will still not affect it if you cancel. It will still cancel. U4 minus U4 still turns 0. So this should have been U4. Do we get? I'm looking for a way to cancel this. They have to be equal. That's why I was like confused earlier. So it doesn't affect it. U4 minus U4 is 0. If it is square, U square minus U square is still 0. Are we together? Change this to U4, U4. U4, U4. Are we clear to that part? Let's just, don't worry, let's continue. So here we have root 2. Now listen now, look at what we want to do. I'm coming up. Now let's split the denominator. So we have integral of u square multiplied by u4 plus root 2u square plus 1 over u4 plus root 2u square plus 1 minus root 2 integral of u square into what? U4, sorry, this one is 2. This one has to be u4 plus root 2u square plus 1 u4 minus root 2u square plus 1. They are sharing the whole denominator. This one share everything, this one also share everything. Now u square, u4 minus root 2u square plus 1. This is, we have du here. Don't forget, please, we have du on both. Share the denominator also. We have u4 plus root 2u square plus 1 u4 minus root 2u square plus 1. So what now happens? This cancel this. What now happens? This cancel this. So what do we now have? We have root 2 integral of what? U square over what? U4 minus what? Root 2u square plus 1 du minus root 2 integral of what? U square divided by u4 plus what? Root 2u square plus 1. We are writing before I clean the board. I think this is the, go for again, like we are very good now, like just write it first, write it first. I will just write it so that I'm coming again to the question. So that when I'm coming again, nobody will be writing again. I'll just be doing explanation. So just write it to it's correct to this part, very correct. Write it to that part. Then I will re-explain again from the beginning so that you can understand, fully understand. So let's just finish it first because I also have to get the answer first. Now don't sleep. If you don't understand number 4, just wait for 5 and 6, I beg. All those people wait there online, they don't go. I'm coming, guys. Just wait. I'll be right back. Be writing. I'm coming. Hello. I'm back. Shall we? Are we done writing? Can I clean the board? Huh? Let's be fast. I hope we've written it. What's time now? 2:11. We should be done by. We should finish the assignment by 3 or 3:30 maximum. We are ending by 5 now. Shade go fast. You that you are just waking up. Okay. 10 to 5, 10 to 5. All those that are sleeping, you cannot do. Don't worry. When exams come every day, TBB. Like Monday, Tuesday, Wednesday, Thursday, Friday. Can I clean up? If there's a way to back, there's a like you can back video. Like on that light now, I think you can back video.
Oh, like to the back.
Yeah. Okay. Because you can be saying maybe I'm cleaning the board, then you back it and screenshot. If you want to screenshot this, back the video and screenshot. Hey, where did I stop? Please, what's the last expression here? The last expression here. Root 2. I'm sorry, I told you guys that we're almost done. So, we're almost done on sharp. What is here? U raised power 4, Abi? Minus root 2u square plus 1 du root 2 integral of u square divided by u4 plus root 2u square plus 1 du. Now listen. Divide everything by. Is this so? Let me remember again. Yeah, divide all through by u square. Divide all through by u square. You have what? Root 2 integral of 1 Abi over what? U square minus what? Plus 1 over u square minus root 2. Agreed. So if you divide this by u square, you have this. Do we get du minus what? Root 2 integral of what? 1 over what? U square plus 1 over what? U square plus what? Root 2 Abi du. Now note u square plus 1 over u square is same thing as u plus 1 over u all square minus 2. It's also same thing as u minus 1 over u all square plus 2. So we are already getting familiar to all this. So now also 1 equals to this one is funny word. Now, do you know why I want to manipulate this? Because of this denominator. Because if I differentiate this denominator, it can give me something at the numerator. Listen, 1 equals to 1 over 2 into 1 plus 1 over u square. 1 equals to 1 over 2 into 1 plus 1 over u square minus 1 plus 1 over u square. Let's confirm. Plus rather. Let's confirm. 1 plus 1, 2 Abi. This is minus. Yeah. 1 over u square minus 1 over u square cancel, isn't it? No, we are not doing multiplication. There's addition in between, so we are not doing. This cancel this. So 1 plus 1 is what? 2. 2 times 1 over 2, 1. So this question becomes root 2 integral. What's 1 now? 1 over 2 is a constant. It can come out, Abi. Okay, let me write it first. 1, we replace 1 with 1 over 2 into what? 1 plus 1 over u squared plus what? 1 minus 1 over u squared divided by what? No, we already changed this guy to this. Are we together? We already changed this guy to this. Okay. Now this guy is going to give us something like we are going to have u. Okay, should I still put this guy there? Yeah, let me still put this. Before I put this, let me still put this. U squared plus 1 over u squared minus root 2. Are we clear to this part? So this numerator is 1 over this. 1 over this. I'm writing this, but all this thing now is equal to 1. Du minus what? Root 2. Integral of what? 1. What is our 1? 1 over 2 into what? 1 plus 1 over u squared plus what? 1 minus 1 over u squared divided by what? U squared plus what? 1 over u squared plus what? Root 2. Oh yeah, right. Everything is correct, right? Then we will now split. We now have like 4 different integral now. Want to split this. We now split the denominator into each. Yes, is this so? What is it? Yeah. I'm looking at this stuff. Let me see where we stop at that. So. Just be writing. Guys, those who are online. Are we done writing? Guys? Yeah, right. It's correct. I just wanted to confirm so that I'm not expecting you guys. Where did you start from? Yeah. Now I want to split all the integral. Now let me split all the 4 here first. Okay. So here we have this 1 over 2 is multiplying everything to the constant can come out. We have what? Root 2 over 2. I need space. Root 2 over 2. Integral. We pick only this. Now don't forget this guy. We can put it there now. Where is it? About this here. Let me check. Okay, yeah. So here now we have 1 plus 1 over u squared divided by what? What is this guy then? This, Abby. So we have so we are using this instead of this. No, both are actually equal. So this will be u minus 1 over u all square plus 2 minus root 2 du. Are we together? This guy is this, and we already said it's equal to this. So instead of writing this, I wrote this there. Then the next one, plus root 2 over 2 integral of this 1 minus 1 over u square divided by, I'm writing this instead of this, u plus 1 over u all square minus 2 minus root 2. Then the next one, minus root 2 over 2 integral of, we're almost done, 1 plus 1 over u square, this is the u, 1 plus 1 over u square, the whole man fit here, this minus plus ló máa fit here, minus to plus, so once we differentiate we get plus, so then we get minus. Okay, minus should be here, this one will fit here, u minus 1 over u all square plus 2 plus root 2 du minus root 2 over 2 integral of the last one now, which is this 1 minus 1 over u square divided by, now we use, instead of writing this down, I want to use the one with positive, u plus 1 over u all square minus 2 plus root 2 du. Are we together? Now I don't want to write another line, so I want to turn this guy to square instead of writing another line. You know, 2 minus root 2 is same as root 2 minus root 2 all square, right? So this one I want to change it. Okay, let's write it. I think writing it is better. Root 2 over 2. After writing the last thing I want to write, the next thing is the final answer. Root 2 over 2 integral of 1 plus 1 over u squared du divided by u minus 1 over u all square plus root 2 minus root 2 all square du plus root 2 over 2 integral of 1 minus 1 over u square divided by u plus 1 over u all square minus root 2 minus root 2 all square du minus root 2 over 2 integral of 1 plus 1 over u square divided by u minus 1 over u all square plus root 2 minus root 2 all square du minus root 2 over 2 integral of 1 minus 1 over u square divided by u plus 1 over u all square minus root 2 minus root 2 all square du. And the next is my answer, because I have a standard integral rather than doing whatever I did. Now there's an integral that says you write it. Note, integration of 1 over s squared plus a squared dx equals to what? Equals to what? 1 over a tan inverse of what? X y plus e. And also integral of 1 over s squared minus a squared dx equals to 1 over 2 root 2 ln x minus a over x plus a plus c. They are standard integral. Both of them, they are standard integral. Now, this integration actually, sorry, I'm coming. Yeah, this integration actually is not just what this one is only valid if what is inside here. What is inside here? excluding the power. Now what is inside there? X. This guy is only valid if what is inside there, the derivative is the numerator. So if you derivative x, you get 1. Are we together? If the derivative, if you have 3 here, this is wrong. You know, you can still have x plus 1 all square here. It's still correct because if you differentiate x plus 1, it's still 1. So it's still correct. So but this one I will have x plus 1 instead of x. So x squared. Here you have your 1. So let's check if the derivative of this is equal to this. If the derivative of this is this constant is not what we are talking about, the variable now. If the derivative of this is this, if the derivative of this is this, if the derivative of this is this, are we together? Now let's check. If you differentiate u minus 1 over u, will you get 1 plus 1 over u squared? If you do, he said no. Wow. If you differentiate u, you get 1. If you differentiate minus 1 over u, you get 1 over u squared. Let's confirm. No, if you differentiate u, you get 1. Now if you differentiate minus 1 over u, the minus 1 over u is same as minus u raised by minus 1, abi? Which is same as minus 1 u minus 1 minus 1. Which is same as plus 1 u raised by minus 2. Then now plus what? 1 over u squared. Isn't it? So u minus 1 over u, if you differentiate, you get 1 plus 1 over u squared. U plus, if it is plus, this will be minus. But assuming this is plus, here you have minus. If you differentiate this, you get 1 minus 1 over u squared. If you differentiate this, you get this. If you differentiate this, you get this. So we can apply those standard integrals. So at the end of the day, the answer to this, since root 2 is common to every, okay, let's leave that one. Let's just write the same thing. The answer to this is what? Root 2 over 2. Now this is 1 over 8. What's like our 1 here? 1 plus 1 over u squared. So here we have what? 1 plus 1 over u squared over 8. What's our a here? Root 2 minus root 2. Abi? Tan inverse of what? X was like our x here. U minus 1 over u. Over what? Over a. Root 2 minus root 2 plus c. This is the answer to the first one here. Now the second one, plus, okay, we can even bring, okay, let's just write them separately. Plus root 2 over 2 integral of, what's like our 1 here? 1 minus 1 over u squared divided by, okay, this one is minus, it's not plus. So this one is following this identity. This one is minus, it's not plus. So it's this identity. So this guy is going to give us what? I'm coming with. This, if you have this 1 over 2 root a, that's the standard, 2 root a. So this one is going to give us what? What's like our 1? This we have plus root 2 over 2, open bracket. Our 1 is like what? 1 minus 1 over u squared divided by 2 roots. What's our a? Root 2 minus what? Root 2, abi? So this 1 over 2 root a. 1, this like our 1, the numerator. 2 roots. Our a is now root 2 minus root 2, which is this. Len x, what's like our x here? U plus 1 over 2, 1 over u, minus a, what's our a? Root 2 minus root 2, divided by u plus 1 over u, plus root 2 minus root 2, plus c. This is the answer to this one. This is the answer to this one. It remains the third and the last one. What is it? Share this one. No, it's minus. Oh. You know we have this one plus separate than 2 minus. No, I did not use bracket. As when I put it in bracket, I cannot change the plus. Do you get? I already splitted it. Now this guy follow the tan one. So our so I'm coming. Yeah, I'm seeing something here. Will it be? It's like no. Is that how it should be? Okay. It's not the same thing. Yeah, I'm like say they will cancel out me, but this is minus. Sorry, this is plus here. We have plus here. Sorry. No, if it's like this we cancel out before. Assuming this plus, this plus. Assuming it's minus, this we cancel this we cancel this. And so we have got but the answer is not 0, so I realize that it's a mistake. Plus. Now let's write the answer for this. So this the guy here give us what? This is the first one, the first answer, the second answer, though the answer should be 1. So the next one will give us minus root 2 over 2. What's like our 1? 1 plus 1 over u squared over what's like our a? Root 2 plus root 2 tan inverse of what? What's like our a? U minus 1 over u divided by root 2 plus root 2 plus c minus, oh sorry, don't mind me. All those c can gather. C plus C plus C plus C is still C. So at the end of the day, we'll be adding C. Plus, oh sorry, minus. Should be minus now. But this has minus. Minus, don't forget that minus is here. Then we have minus. Now the last one, that one follows the link 1. 1 over 2 root A. 1 over 2 root A. What's our A? Root 2 plus root 2. Ln absolute value, because ln of negative is undefined, but absolute value. What's like our x? U plus 1 over u minus, what's our a? Root 2 plus root 2 divided by u plus 1 over u plus root 2 plus root 2 plus c. That's the final answer. Let's write it down. Let's write it down. That was the final answer. Yeah, your friend will send it to you. Don't worry. They are. That's the correct. That's the correct answer. Just write it neat. It's correct. So you guys don't sleep yet, though. We still have 2 more to go. Can we see the board? Can we see the board, guys? Don't mute Lawson. Nifemi, are you there? You know easy. Yeah, let's write it. I hope those that are sleeping, their friends are writing. They are sleeping. I have a friend that is writing. No? Will it contain that one page? Eh.
I don't even know how to do it.
Okay. Okay. Please write it very neat and very correct. Can snap and send to your friend. Don't mind mass department. You should have taught it physically now, so you can send to anybody. Spread it. Let them copy and paste. The man gave them something like this in 2021 test, not even exam. Keep root of tan left. The difference is not far at all. The difference is not far. Keep root of tan left. In test, number 5 question, not even exam, test, German, not the video. That you have to solve. It's out of everyone who did it, I think only 2 people did it. Like that they got 2 people, others. He taught them, I think, a day before the test. When he attempted the question with them during the lecture, and the test was the second day, he brought that question out. We don't smoke. It's not easy now to be the best analysis mathematician in the whole of Africa. Is it good? You don't know. Murphy good. Go and check on Google. Yeah. Murphy good on Google. Analysis. Google is very good now. So it doesn't even need textbook to set question for you. Just gonna read this biography. Everything is stated there. Can we move?
Yes.
Even that man that is teaching Math 101, that man too. No, there are 2, a woman and a man. That man guru. During our set, I think he traveled to UK then. He was the one that he taught us first before the woman took over. Can I clean the board? Yeah, let's be fast. Especially that number 6, that one is very simple. It's number 5 that we'll be doing something related to this, but I don't think it's up to half of this. And it's straightforward, that number 5. Yeah, it's straightforward. I can clean the first line, right? If your friend is sleeping, please help them to write it. Now. Write this thing. Make sure you write it very well. You may not even need to write this one. And you may write. There is no problem. No, this guy too, this time, you can write it in form of claim. Yeah. But because of this plus, the numerator will not be plus, the denominator will be minus. It can be either. But this one cannot be written in form of term. If it is minus, you can't use term. You can only use plus for term. But if it is plus, you can use both lane and term. Now, integral of, is it cot x or root cot x? What did they do this man now? Which are they give everything root? Integral of root cos x dx, right? So let you be what? Root cot x, right? You say let you be root cot x, that means what? U square equals to what? Cot x, right? Let's differentiate u square. So 2u du, isn't it? With the many cot x, what do we get? Minus cosec Is it cosec square x or cosec x? Does it have square? Let me confirm. I don't want to forget those things. I think you should have square.
That's good.
Okay, all right, good. You are good to go. Now, note. This identity. One. Do you remember this identity? Okay, let's start from this. Sine square theta plus cos square theta equals to 1. How do we beget cosec? Cosec is 1 over sine, are we? This is cos 1 over sine. So divide everything by sine. Sine square theta, sine square theta, sine square theta. So this gives us 1 plus what? Cos. No, cos of sine over cos is tan. So cos square theta equals what? Cosec square theta, right? Isn't it?
Yes.
So which means if this one comes to this side. Now since we have minus here, okay, let's multiply both sides by minus to make sure that this guy is positive. So that means here we now have what? Minus 2u du, abi, equals to what? Do we agree?
Yes.
Yes.
If the minus was here, we can bring it here. If a is minus c, that means c is minus a. So since note cosec square x equals to what? 1 plus what? Cos square x, isn't it? Which means therefore minus 2u du equals to what? 1 plus what? Cos square x. And since note again, cos x equals to what? Therefore cos square x equals to what? Therefore minus 2u du equals to what? 1 plus u raised by what? 4. Sorry, we have to add the x here. Do we get dx? Then this one too is what? Dx. No, if you say du here, dx on the other side. I hope that's clear. Dx. I hope you are written it. So here we have what? Now making the x the set of formula, that means dx equals to what? No, to all those things I'm putting there, but they are not in straight line. So that means all those things they are what? Dx equals to minus 2u du over what? 1 plus u raised to power 4. Yeah.
Write the question.
What's the next thing there?
We write the question.
Okay, let's write the equation first. Therefore, we have integral of what? U, because our root cos x is u. We can bring out minus.
Yes.
I want to use that too. That's why I'm not bringing it out. You can, if you bring it out first, if you need it, you take it back in. Dot what? 2u du, right? Over what? 1 plus what? So equals to minus integral of what? 2u square over what? 1 plus u raised to power 4 du. Are we together?
Yes.
Is it clear? Now divide all through by u square. Is that so? 1 over u square, u square. Is that so? Let me remember. Okay, be writing it, I'm coming. That should be it, but I don't want to make mistake. I'm coming. So let's remove the 2. Equals to minus 2. Yeah, let's remove the 2. Yeah, there's no problem. Now we go to the part. Note u square equals to what? I mean, let's not remove it. 2u squared. Let's keep it that way. 2u squared equals to u squared plus 1 plus u squared minus 1. Abi? U squared plus u squared, 2u squared. 1 minus 1. Gone. So the question now becomes minus integral of what? U squared plus 1 plus u squared minus 1 divided by what? 1 plus u raised power 4 du equals to minus integral of u squared plus 1 over 1 plus u raised power 4 du minus, because of this guy, it's multiplying everything, minus integral of what? U squared minus 1 divided by what? 1 plus u for what? Du. We're almost done with this. Let's write it so that I can feel the board. I don't write it. Spread it, spread it. Spread everywhere. Everywhere. Are we done? Let me clean the question. No, just down. Minus. Like we are splitting it. You know, if this minus multiply this minus. If it multiply this minus. This minus. Because of our minus. There you are. Divide 2 by u squared. 1 over u squared. Okay, we can write it out. Now let's move. Divide all through by u squared. So we have minus integral of what? 1 plus 1 over u squared, isn't it? Over what? 1 over u squared plus what? U squared du, Abi? We are dividing all through by u squared. Minus what? Integral of what? 1 minus 1 over u squared. Write it there. Divide through by u squared. Over u squared divided by what? 1 divided by u squared plus what? U squared du. Are we done? Shall we? Now this guy here, note 1 over u squared plus u squared equals to 1 over u, thank you, plus u all squared minus 2 is also equals to 1 over u minus u all squared plus what? Plus 2. Let's confirm that. 1 over u times u 1. Yeah, that's correct. Are we done with this line? Okay. So the question becomes negative integral 1 plus 1 over u squared divided by, which one should we use out of these two? For the denominator of this one? The negative, because if we differentiate, it becomes positive. So here we have what? 1 over. Wait. We are writing it this way. U plus 1 over u. U minus 1 over u. Let's check. It should be written in this form. U square 1 over u. Yeah. It is this one that should have the negative. So here we have what? U minus 1 over u all square plus 2, right? But I can change plus 2 to what? Root 2 square. Now we can have x squared plus a squared. Do we get? Du minus integral of what? 1 minus 1 over u squared divided by, now I'm using this positive part now, divided by u plus 1 over u all square minus what? Root 2 square, which is same thing as minus 2. So du. Therefore, my final answer is, since if I differentiate this guy, I'm going to get this. So my final answer is 1 plus 1 over u square divided by root 2 tan inverse of what?
U minus 1 over u.
U minus 1 over u divided by what? Divided by root 2 minus 1 over 2 root a. What's our a? Root 2 ln absolute value a x here. U plus 1 over u minus root 2 over what? U plus 1 over u plus root 2. Plus c. Please don't forget that c. This is the answer. You can see this one is direct. Like, it's not really. Yeah, that's the answer. Very correct. Very, very correct. Now the last question. Because this one is sparking our brain. I will explain the last question, so just don't just write. Pay attention. Pay attention rather. This one says, I explain now. I don't bring Gary. Hello guys, are we following? Who is wizard? Hey, they say that man a wizard. Make it go here. Are we there? Hello guys, we don't sleep. Oh shame. Ṣé kan tí mo ṣe báyìí ṣó yẹ tó mi àbò kan wòran? Don't worry, people that are here, they are writing. They will snap to you guys tomorrow. Now the last question. Almost. Are we done?
Yeah.
Did you finish writing down? Are we done? Let's be fast. I hope some of us finish writing that for Tutor Belloᵈಛ. Those who are told, they are depending on you. Can I clean the board? Or I can clean the down part. Let's not sleep. We have one more, just one more. Yakubu will manage. You feel like I want to die, but you will not die. Yakubu manage. You feel like I want to die, but you not die. Is that okay? Integral tan raised power mx, right? Over what? Sin x cos x dx. Is that the question? That's the question. Please, let's check. Let me confirm. That's the question. I want to use. Are we done with this? Let me start from up. So we game us work like this. If I know this thing, my 100 level say I'm almost together. I don't know. I don't know actually. No, other questions here. They are still normal, but that portrait. Well, it's not bad, no, sir. Are we done? Can I change the word? I see the people are sleeping in my faculty, like they are not feeling mosquito, they are enjoying their sleep. Like TLT, can't sleep in peace there. Walk. TLT. So that I will wake up at TLT, I will see blood on my body. Mosquito. All the mosquitoes they are big, like they are lifting weights. I don't know. Those TLT NFL mosquitoes, they are not from this world. Can I clean this board? Don't forget plus CO. Can we clean? We can. Àwọn Yakubu dé sùn. Yakubu ẹ manage. Right for a zero call. Tó bá ti wọ second semester ló ti ẹ̀ ní lọ kíláàsì mọ́. 500 is good. I want to make my mama proud. There was this guy. He's not a graduate. He graduated from maths department. I think when I wanted to enter the level, graduated from here. Said, oh, this song. Come on, my bro, be proud. Come up and be proud. Olóò ṣì lára àbúrò tó lè be proud olóò kì í ṣe ọmọ tó ń proud bí a ti wojú ẹgbẹ́. This guy is mad for real. Integral of what? You guys have not seen anything.
Over sin x. Is that?
What is it? You have not seen anything now. Enter second semester, then enter 200 level. Second semester is still coming now. Second semester is kind of, though it's less bulky to some people, it's kind of more bulky to some people. But you have not seen anything. If you are, how many of you have been PS 102 here? Yeah, almost all of you. PS 102 is like no 101. If you don't, you better go and learn 101 very well. All those vectors. Because now be applying vectors to electricity and magnetism. 102. Like all those Coulomb's law, all those things, now be using vectors to solve them. Magnetism, when you get to, especially when you get to magnetism, and get to Sabbath law, Ampere's law, all those things. That Sabbath is the most confusing as the student don't understand. But I have a write-up on it already. Just read the write-up. You'll be set free. It's still on my channel, Sha. When the time is come, I will send it out. Integral of tan of m power of x over what? Sin x cos x. Now, what we need to do now, we need to invoke tan as the denominator. I want to invoke tan here. How can we turn this guy so that I can give birth to tan? Now, sin x cos x equals to sin x cos x times cos x over what? Cos x. Isn't it?
Yeah.
Equals to sin x over cos x, right? Times cos square x. Am I right?
Yeah.
Take this down here. Then this times this, you get this. Equals to what?
Tan x plus square
Tan x cos square x. Equals to what? Tan x times what? 1 over what? Sec square x. Equals to what? Tan x over what? Sec square x. That's the beauty in math. So here we have integral of what? Tan raised by m x over what? Tan x over what? Sec square x dx. Sec square x can go up, right? So here we have what? Integral of what? Tan x raised by m sec square x divided by what? Tan x dx. Note. Tan mx over tan x equals to, no, it's just like then called the one that we understand. Am I right?
Yeah.
Maybe this square, you can break it out. Equals to tan x raised power m minus 1. Are we together? So the question becomes integral of what? Tan of m minus 1x or tan x all into bracket m minus 1. That will be 2. Sec square x dx. Now, what should be my u now? What should be our u? Yeah, tan x. I don't forget that there is tan x here. No, there is tan x here. This m minus 1 minus confused is just like number. Do you get? So maybe we should just write it so that it can be clear. So here you have what? Tan x, right? M minus 1. Now if you have tan square x, you can write it as tan x all into square. So here we have what? Sec square x dx. So let u be what? Tan x, such that du over dx equals to what? Sec square x. Therefore, the x equals to what? Du over what? Sec square x. Therefore, we have what? Integral of what? U raised power m minus 1 sec square x. What's our dx? Du over what? Sec square x. Far. Equals to integral of what? U raised power m minus 1 du. So let's integrate this guy. Give us what? U raised power m minus 1 plus 1, abi? Over 1, abi? There's only 1 we had. Wait. No, over what? M minus 1 plus 1, abi? Plus c. Equals to what? U raised by m, abi? Over m plus what? C. What's our m? Equals to what? Tan x raised by what? M over m plus c. That's all. Thanks that this one is interesting. Hello guys. Let me confirm the answer to that last one. I'm losing my mind though. I mean, don't lose your mind though. Don't lose your mind though. Everything you can show me. Don't lose your mind though. Sorry, everything is gonna be alright. So here we are done. What's time now? How many minutes? 309. Wow, we are fast. So we continue by 3:30.
So we have a break.
Yeah. We start Math 101 by 3:30. Math 101. Quickly want to do some play, they slept. And Queen is slept. You quickly want to do some play. Which topic do you find difficult in 101? Another guy knows. Another guy knows. It's the simplest topic now. But they cannot ask you in the exam. Forget it. So we won't waste time on that. 3. Did you come out in the test?
No.
You might play with 3, but it's not a priority. Complex number is simple now.
What we do today is the
Simple. For real, everything in 101 is simple. It's simple.
and it's obviously let's learn something about it.
I don't even know which one is hard. Like everything 101 is permutation and combination. Did they later teach you guys permutation and combination?
No.
I'm sure. But they teach you guys polynomial.
No, they said we should
Is that you should learn it yourself? Wow. Wonderful. Expect it in exam.
Sure.
Your exam might be up to 40 or 60. Even with that did German, our exam was 35 questions. That we did German, no talk of open.
I've said it.
For 101.
I
But
don't
102 was 9 questions. That 9 questions.
like my mind.
The thing is that you know some of them was just mistakes. Let me not remember all those past pain. I was solving to an extent that one of the invigilators came to my, was like, what department are you assessing at? I said, don't do that. I will still score 40. I have 40 in the course now. For all those mistake, just that your own is OBJ, that's why you have lost. If it is German, forget it. It's not about how brilliant you are. If it is German, you make single mistake, all your stress is gone. You can score 0 for that particular question. There's a question there we are asked to integrate something like this. Integral of root a minus x over is x plus a or a plus x, either of the two here. For me to break this guy down, I used 2 pages. So I later got the integral of cos square x here, which is correct to this part. Like the breakdown, not the integration. Now for me to start the integration, this one have an identity. I think 1 minus cos x over 2, something like this, if I'm not mistaken. But I did not remember, I forgot. So I now use reduction formula. So there's a part of that formula. If your trig is, if the power is greater than 1, so reduction formula is applicable. There's a part that I should have written n minus 1 over n minus 1 over n minus 2. So I now wrote 1 over n minus 1. So the question where I ought to get 1 over 2 in the final answer, I got something like 1 over 4. And the question is 9 marks. You score 0 there for it. Once your answer is different, you score 0. That's the terrible thing in German. That's why you guys are lost. You guys are still scoring 5, 9, 7 your test. Those are good scores now. If I show you our PDF score then, we are binary numbers. 0 over 15, 1 over 15. Those 1 over 15, they are attendance mark. 1 over 15, 1 over, you can check like 200 scores. You only see like 5, 3, 5 in the middle. Others 1, 3, 1, 1, 1, 1, 1, 1, 1. 3, 3. And I'm not exaggerating, that's how it is. Because for German, make single mistake, everything is 0. That's just, but you guys, OBJ, it's kind of, so you should do well, you should pass, that's just it. So some people still got 70 in the exam now. Some people get 2 head, let's not lie, some people have 2 head. Some people have 12. 70-70. It has 13 over 15 in test. 70-70 in exam. 98 over 100. It's in computer science. Another person have 94 over 100. It's in maths department. About 4 people I shall have 70-70 in the exam. But we shall thank God, shall. God gave me my own score. Such is life. I see it for 101. I think I have 82 in 101. So, but 101 is simple. That's good. If you can pass it, you will pass it. Unlike 102. You may be able to pass it and not pass it. But since you guys are doing OBJ, you shouldn't have problem. For real. It's a great luck for you guys. If you know what is German, then you know that you guys have a big luck for doing OBJ. That German, just read, be brilliant, then pray for grace, pray for accuracy, pray for calmness. Are we done? It's 3:30 now. So which topic should we do in 101? Trig. Like proving. Like we should be proving. Show that this is this, have you? Why is all of you mentioning trig? Show the woman has said, like she said, she will fail you with trig, have you? What aspect of trig are we to prove? Okay, let's play with trig. Now you should know that as 100 level student, you have to know at least 30 identity of one. Like without, like effortlessly, 30 identity. Like effortlessly. Can I clean the board?
Yes.
If you don't know trig very well, you have problem with calculus, integration. Like big problem, like terrible problem. You don't know trig very well. We still have like 1 hour to do 102 today. There is some aspect of trigonometry substitution and integration I want to teach us. Very important. Now let's start with trig. Let's just put some few identities. Now starting from it's not yet 3:30. What's time? I'm sorry. No verse, I'm sorry. Who is fleeting fleet? Abi, what's it called? We don't have mosquito here, so please don't lie. You don't have to do any fleet. We don't have mosquito here. This is not TLT. And this is not KDL. KDL has both mosquito and bed bugs. I can never read. Go for it. Let's be telling stories then. Please, read you. It's very important. Don't joke. Use this 100 level to build your CGPA. Like worst the like it worst just have 2-1 second class upper, and let that upper be on 4 point something. I don't even know how they calculate CGPA. No, we are this 5.0. So from 4.5 to 5.0 is first class. 3.5 to 4.49 is second class upper 2-1. 2.5 to 3.49 is second class lower 2-2. 1.0 to 2.49 is it 1.0 or 1.5? I think 1.5 if I'm not mistaken, because with third class. Then 1.0 to 1.49 because we pass. So at least just fall here to be very okay. Because 100 level, if you don't build it in 100 level, it will be very, very difficult. Very difficult. Like, very difficult. Those, we have some people that falls here, and at the end of the day, they came out with first class, but it's not easy. It's not easy at all. It's not easy. And please do everything you can not to have carryover. So don't say God forbid you cannot have it. See, it's very easy. No. Don't say God forbid you cannot have it. Just trust God and work very easy. Like, it's one of the easiest thing in UI to carry over course. We sabi book like mad, but you can. I have a lady in computer science. Before we resumed our 100 level then, we were doing an online class. This girl, she understands math more than I do, like very well. She carry physics 101. Carry over, she have 3400. Carry over is very easy, forget. Like it's like gift card in UI, gift card. Whether you are brilliant or you are low. Although you load the gun, the man carry over. So please, and do you know what used to happen at times? Sometimes when we are reading, we read to a point that I feel like I don't kill myself, I'm tired. Is it that one that you did not read? See, that one that you did not read, trust me, it will come out. So please, if you can, and no, there are times that you will read to an extent that if your result come out, even though you don't have A, you know that there's nothing you want to do to pass more than that. You know that you've done all your best. You don't get what I'm saying? For instance, even though if you have 59, you know that this 59 is the length at which you could go before the test. But there are some reading you do that even though you have B, you will regret. That night, if I no sleep, if I don't enter 70 now. So please, there are times that you just have to just devote that time. Give your best. Give your best. They are very, very important. And some of you that you prefer calculation to reading, like me now, all those reading courses, I hate it with passion. I did not just dislike them, I hate them. That's why education is giving me problem. All those reading history, they are giving me big problem. To an extent that I did not even do biology my wife. All those stories I hate. I replace it with further maths. So please, if you are having issue with reading, or you love biology, you don't love physics, they play. You can read, you cannot calculate. Please just try as much as possible. Read whatever you can read. And during your test, if you are doing maybe your second test, I don't know if it's going to be online. It's going to be written, whether online or written. Whatever help you can give people, give them before you enter the exam. Once you enter the, if they catch you, I see that you leave the school. I've seen people leaving school. Even I'm still in second year now, I've seen people leaving UI because of my practice stuff. They have given me -10 before in 100 level, physics 101. I should have 70 in that course, I have 60. I was talking with my department member, we sat together. And the man just wrote -10. I thought it was a joke. I have 28 in test, I saw 18/40. And I got 42 in exam. I'll be 60/100. Especially that physics department, they are not joking. Maths department, we know them to be wicked already. But physics now, you are not seeing wickedness in them, but wickedness is inside them. People carry over physics than maths. Even maths 102, people carry physics than 102. Even 101, people carry 101 than 102. What the issue we had with 102 is that about 90% got 40, 40, 40. Yeah, more than 90%, 40/100, 40/100. But the rate of those who carry 102 is even far less than 101. 101 carry over plenty. So 101 is not, it's just that if you understand it, you know it, you will pass it. That's just it. Unlike math 102 then, even though if you understand it, you can still bang. Though now that it's OBJ, it shouldn't be like that anymore. Now that it's OBJ, that's just. But during jam and then, that you know it's not a guarantee that you will pass it. So please just fight. Not as if you are beating the air. Just fight a good fight. Please focus on your. Be focused now. Just be focused. Every other thing, forget it. Forget it. Except if you have another priority. Maybe you have another priority. Some people, they have priority on business. They just want to get certificates. Then probably you can divide your focus. But if your priority is this thing, please focus and have what you want to have. And please don't just come to school to have paper. See, hunger go kill you for this country. You finish school with first class. At the end of the day, the only thing you could do is to sit down in one office, be collecting 200k every month. You will suffer. In this Nigeria, 200k. Is that money? I asked a lady in computer science, I was like, what's your intention? What do you plan to do? Like if you see, after you graduate, if you see one job like 500k per month, will you he said, of course, 500k is very big though. In this Nigeria, 500k per month is rubbish. For real, I'm not kidding, it's rubbish. Have your work. Your work is what you can give to your society. It's different from your job. Though your job is what you are giving to also to the society, but you are giving it on a salary basis. But your work is what you are giving to the society because you have the value, you have the content, and it's not on a salary basis. It comes anytime you give it out. For instance now, as a physicist, as I am, still trusting God actually. Or let me say as an education and physics as I am, because I'm also a teacher. And I came out with first class. And I was asked to come and teach secondary school students, SS3, O-level physics. They want to write white. And I couldn't teach motion without opening new school physics from A to Z. Then all my years in higher institution is a waste. I have to open it from like a copper then. A copper I can't forget in my SS1. It will cram definition to come and be teaching us. That's nonsense. How did you get to that copper? How did you get there? You used 4 years in school and motion. You are still cramming you don't even know, you can't do. A copper in biology, a copper taught us in biology next week. He gave us a definition on photosynthesis. When the real biology teacher came to teach us, he said we should define it. So some of us now open the book to just define what the copper told us. And the man said, that's a very bad definition. I was like, sir, now copper give us now. So now, how did you get to that level of NYSC? And yet you are not yet granted at your field? It's very, very, very bad. It's so bad. Even me now, I cannot go for student teacher and see my students will enjoy me. Just student teacher, not copper head though. They will know that somebody. In fact, if I want to go back, they will not allow me to go back because they know that this person that no, cannot lose him. Because see, you should be very good. For instance, okay, you even do MBBS at the end of the day. Maybe they brought a patient to you. Cannot, is it diagonal, they call it now, until you consult AI. Then you have wasted 7 years in school. And I've seen it happening before. My economics teacher in SS2, his daughter was sick. He took her to the hospital and the doctor said he's coming, and about 30 minutes they did not see doctor. So my teacher was like, let me just go and see The man was consulting AI on what to tell the patient of what is happening to her. Why did you go to school for 7 good years? Is that not madness? And you spend 7 years in school and you cannot treat a patient. Ah, God forbid o. How might I reject it? God forbid. Or you spend 5 years in school, 4 years as an education, you cannot teach. You are teaching your students, they are like every time. I just go out, let's finish. When you are done, let's just know that I have come. And there are some teachers that they don't know your course because they don't like you. They don't like you because your teaching is boring. Your teaching is boring because you don't know what you are teaching. You don't know what you are teaching because I don't even know what to say again. So please, even as a computer science student, don't just have the certificate. If you are in school, learn coding, learn JavaScript, whatever you can learn, back end, front end, everything, learn them. Whatever you are able to, whatever your hands finds to do it with all your might. Because at that grave, there is nothing to do again. I have seen so many talents being wasted, so many potential being wasted. So there are a lot of things you can do. For real, trust me. I started a project in 100 level, while in 100 level, on how to generate electricity using water. It's in my lab there, but my money was not enough. I'm going to complete it before I get to 300 level. So that's what we are talking about. How did I get that knowledge? From electromagnetism. Even right from my secondary school, that's when I learned it. Right from SS2 or SS3, electromagnetism. So these are what you can just do. Don't just read theory or don't read for theory's sake. Also learn the practical aspects. Is it 3:30 already? So please, those things are very important. There are doors that paper will open for you. The fact that you have first class, someone that doesn't have it may have more opportunities than you. But the fact that you also know what you are doing, even somebody with first class may not have the opportunity you have. So you need both actually. You need both. Now, let's start with the unit circle of radius 1. The first identity you should never forget is sin square theta plus what? Cos square theta equals to 1. Many other identities are derived from this guy. Not many others, sorry, few rather. Now, let's get the second identity. The second identity is derived by what? Dividing all through by what? Sin square theta. We will divide by sin square theta over sin square theta plus what? Cos square theta over what? Sin square theta equals to 1 over what? So here we get 1 plus what? Cos square theta equals to what? Cosec square theta. No 1 over sin is cosecant. Share this. This is cot. Cot, sorry, I wrote cot. No, sin over cos is tan. Cos over sin is cot. Now let's divide this all through by cosec cos square x. Sin square theta over cos square theta plus cos square theta over cos square theta equals to 1 over cos square theta. This gives us what? Tan square theta plus 1 equals to what? Sec square theta. So these three identities, they are very, very important. How do we derive this? Divide the first one by sin square theta all through, you get it. Divide that same thing by cos square theta all through, you get it. So these, they are very important. Now another identity you need to know, that's three identity already. That you need to know that we derive a lot of identity from is what? Sin A plus or minus B equals to what? Sin equals to sin A cos B plus or minus what? Cos A sin B. What do I mean by plus or minus? At least if this is plus, you have plus here. If this is minus, you have minus here. Are we together? You must never forget this. Another one you must never forget is what? Cos A plus or minus B equals to what? Sin A sin B minus or plus cos A cos B. That is, if you have plus here, minus will be here. So plus or minus, minus or if you have minus here, plus will be here. If it is cos A plus B, it will be sin A sin B minus cos A cos B. is cos A minus B to be sin A sin B plus cos A cos B. But for sin, whatever sign you have here, you have it here. Whatever sign, but this one the sign will change. So now for tan A plus or minus B equals to what? Tan A plus or minus tan B over what? 1 minus or plus tan A tan B. That is, if you have plus here, there will be plus here, there will be minus here. If you have minus here, there will be plus here. If you have minus here, there will be plus here, there will be sorry. Yeah, if you have minus here, there will be minus here, there will be plus here. That is tan A plus B will give us tan A plus tan B over 1 minus tan A tan B. Tan A minus B will give us tan A minus tan B over 1 plus tan A tan B. Are we together?
Yes.
So those are the things you need to do. Now, other identity now we begin to generate them. Now, how do we derive sin 2 theta to be equal to 2 sin theta cos theta? How? Now we are going to prove it now using this identity. Now I can write sin 2 theta. Sin 2 theta can be written as what? Sin theta plus what? Theta, isn't it? So I can, no, theta plus theta is 2 theta. So I can replace A and B with theta theta. So since sin A plus B equals to since sin A plus B equals to what? Sin A cos B plus what? Cos A sin B. So sin theta plus theta equals to what? Sin theta plus what? Cos theta plus what? Cos theta plus what? Sorry. Sin theta cos theta plus what? Cos theta sin theta, which is same thing as what? Sin theta cos theta plus what? Sin theta cos. You know this is like 2 times 2 with 3 times 2. Cos theta. Sin theta cos theta plus sin theta cos theta. 2 sin theta cos theta. Are we together? Is that clear?
We have to send it out.
If you have A plus A equals to what? 2A. If you have AB plus AB, 2AB. If you have sin theta cos theta plus sin theta cos theta, 2 sin theta, that is, you have 2 of them. Leave that. Now, there are many identities. Let me remember the. We also know that. Okay, I'm coming.
Cos A plus B should be cos A cos B minus sin A sin.
Yes, that's what I heard. Here I put plus or minus, here I put minus.
Sin A sin B minus cos A cos B cos A minus.
Okay, this first time.
Yes.
Sorry. Cos A cos B minus or plus sin A sin B. Yeah. Sorry. So now, let's check for cosine. Cos 2 theta. Let's see what cos 2 theta is equal to. Cos 2 theta equals to what? Cos theta plus what? Theta. Which is same thing as what? There is an identity. Let's see. Which is same thing as what? Cos theta minus what? Sin theta. Which is what? Cos square theta, right? Minus what? Sin square theta. Note. Cos theta, I think it has 2 different identities. So it depends. Now from the first identity, sin square theta plus cos square theta equals to 1. Let's make sin square theta the surrogate of the formula. So that means sin square theta will give us what?
1 minus
cos square theta. Now substitute it here. So this guy give us what? Cos square theta equals to what? Cos square theta minus what? 1 minus what? Cos square theta. No, sin square theta is 1 minus cos square theta. Note, cos square theta equals 1 minus sin square theta from the top. Therefore, this guy equals to cos square theta minus, instead of sin square theta, we have 1 minus cos square theta. So here we have cos square theta minus 1 minus times minus. So we have what? Plus cos square theta. Cos square theta plus cos square theta. So we have 2 cos square theta minus 1. That's an identity for cos 2 theta. Do we remember the identity? We have forgotten. Oh. So it's also equal to, which is also equal to 1 minus 2 sin square theta. Let's prove that one. Are we done with that part? I can print that part, are we? So, if here we have now also note, if note cos square theta equals 1 minus sin square theta, abi we make cos square theta the result of the formula. We have 1 minus sin square theta. So let's substitute into this. Therefore, cos square theta minus sin square theta from here is going to give us what? Instead of cos square theta, we have what? 1 minus sin square theta minus what? Sin square theta. So this guy gives us 1 minus sin square theta minus sin square theta. Minus sin square theta minus sin square theta. Minus 2 sin square theta. That's another identity for cos 2 theta. Are we together?
Yes.
So the identity I said I even forgot that day that I need in integration. I already used 2 pages to disintegrate the question to give me integral of cos square x dx. Part of tension, I forgot this thing. Now, cos square x, I can bring this simple identity that if I can just integrate, I will just get it. Now, I can see cos square here, right? So, you know, from there, I said, that's why I said you also need trig in integration. I said cos 2 theta is what? 2 cos square theta minus 1, abi? Take this to the other side, you have what? Cos 2 theta plus 1 is what? 2 cos square theta. Divide both side by 2, that means what? Cos square theta equals to what? Cos 2 theta plus 1 over what? Over 2. It's very easy to integrate this guy. Assume I have this guy here. Cos 2 theta, or let me say 1 plus anyone like that. 1 plus 2 is 2 plus 1. 1 plus cos 2 theta over 2. Now if I have this guy here, cos 2 theta over 2. Very easy. Half can come out. I will have 1 over 2 integral of what? 1 plus what? Cos 2 theta. Who is going to give me what? 1 over 2 integral of 1 d theta plus what? 1 over 2 integral of what? Cos 2 theta d theta. If I integrate 1 with respect to d theta, I get 1 over 2 into what? Theta plus c, right? Let me leave plus c first. Plus 1 over 2 into what? If I integrate cos 2 theta, what do I get? If I integrate cos 2 theta, sin 2 theta over what? Over 2. So this guy give you what? 1 over 2 is common to everything now. So here you have 1 over 2 into what? Theta plus what? Sin 2 theta over what? Over 2. That day I got 1 over 4 here. And 9 mark is gone. I got 1 over 4 here plus c. Every this thing they are correct. But because of that, n minus 1 over n minus 3, that reduction formula, because this identity I do not remember it. In this place I put 1 over n minus 1. So you change this guy to 1 over 4. Any more mistakes there? But you count the mistakes I make then of things I know very well. More than 40 marks gone.
No.
Show this one. I know the integration. I'm not doing this. This is another identity. You write it, add it to it. So please don't just cram them. Know how to prove them. Then to tension them because I think I know how to prove with them. But did I think so? I'm not sure, Sha. It's like we cram it them. But I think it was all about tension, Sha. But if you don't remember something and you can prove it, it will help you a lot with just all those. And at times, for you to even memorize something very well, it's as a result of the proving you have been doing. So those things will just stay in your head. Is that fortune of Tanet? Direct. Fortune of Tanet. You are right. No, she's even writing it. She's confused of. She was looking at it. What was this now? Are we done? Now let's see this guy too. I think we've derived about 5 or 6 now. Let's derive another one from this. Now don't forget that same cos 2 theta. That same cos 2 theta equals to what? 1 minus what? 2 sin square theta. No, initially we equate it to 2 cos square theta minus 1. Now take this. I'm coming. Yeah. Take this guy to the other side. You have 2 sin square theta equals to what? 1 minus cos 2 theta. Please don't mix them up. We usually mix this plus and minus. So here we have sin square theta equals to 1 minus what? Cos 2 theta over 2. For sine, you have minus. They are the same, but for sine, it's minus. For cos, it's plus. Are we together? Are we done? Now for you can also have sin theta equals to plus or minus root 1 minus cos 2 theta over 2. There are places that this one they are also applicable, like they are needed. Same thing with that one. Cos theta equals to plus or minus root 1 plus 2 theta over 2. I'm just forgetting those identities. Let me remember. Then I'll be proving them. They teach you guys prior fraction in 1 1. Not really, but I know how they teach you well. I heard they teach you. All they teach you, forget it. There's nothing like not doing in UI. But I think all those maths lecture in 200 level. I think if you do maths in 200 level, you will enjoy it. Like some new, like they teach very well. Like to me, it's beyond lecturing because like they teach it. The way I'm teaching, they teach it. It's 100 level that has more sense. I'm probably, especially math 201, that woman, she explains. Well, to some people, it's like they are still reading slides. I think it depends on individual. Can I clean the board? So that I don't get 200 level and you don't enjoy the class. But below said it there, no, that guy must be lying. So it depends on individual stuff. Yeah, what are the other identities we have so that we can prove them? I don't forget those. I know I can. This my YouTube is still on, Sha. Yeah, the last one is correct. Okay, you guys can go. Let's call it a day. Not we that are here. Bye bye. I don't even think all those 11 that are here, sef. We haven't got this one. Don't turn phone sílẹ̀. Àwọn ọlọ́mọ. Bye bye you. you want to repair phone, I repair phone. I'm an engineer. If you rent apartment off campus, you want to do home wiring, I do it. I do furniture. I produce paint and I also paint room. If you want to do any of those things, don't take my work outside and I'll give you the cheapest price ever. I'm like doing everything.